WASSCE 2025, Core Maths, question number 1. A bus travels between two stations, Paga and Kappa, covering the first half of the distance at an average speed of 60 kilometers per hour, and the second half at 90 kilometers per hour. The total distance between the two stations is 300 kilometers. A. Calculate for the entire journey the average speed of the bus. B. If the speed of the bus in the first half of the journey is reduced to 50 kilometers per hour, determine its effects on the overall time. So, solution A. We are told that the bus traveled from Paga to Kappa, and then this distance or journey is divided into two equal halves. Okay, so the first half, the car covered 150 kilometers, and then the second half, the bus covered another 150 kilometers, totaling the 300 kilometers between the two stations. We are told from the question that the average speed used by the bus to cover the first half is 60 kilometers per hour, and the average speed it used to cover the second half is 90 kilometers per hour. So our main aim here is to calculate for the time the bus took to complete the first half and then the second half. So we say distance covered for the first half is equal to df, is equal to, according to the question, 150 kilometers. The average speed for the first half is equal to SF, and according to the question, 60 kilometers per hour. The time taken for the first half is equal to TF, is equal to distance over the speed. So what is the distance? The distance is 150 kilometers, and then the average speed here is 60 kilometers per hour. 0 cancels 0. 3 goes into 6, 2. 3 goes into 15, 5. So it is equal to 5 over 2 hours. So the bus used 5 over 2 hours to complete the first half of the journey. So let's look at the second half of the journey. The distance covered for the second half is equal to ds, is equal to also 150 kilometers. The average speed for the second half is equal to ss, is equal to 90 kilometers per hour. Time taken for the second half is equal to ts, is equal to distance over speed. So the distance in this case is also 150 kilometers over the average speed of 90 kilometers per hour. So 0 cancels 0. 3 goes into 9, 3, and 3 goes into 15, 5. So 5 over 3 hours. So we say that the bus used 5 over 3 hours to complete the second half of the journey. So now, total time taken by the bus is equal to T, is equal to the time taken by the bus to complete the first half, which is 5 over 2 hours plus the time taken by the bus to complete the second half, which is 5 over 3. So let's find the LCM of the denominators. The LCM of the denominators is 6. 3 goes into 6, 2. 2 times 5, 10. Plus 2 goes into 6, 3. 3 plus 3 times 5, 15. So this is equal to, you add the numerators, it gives us 25 over 6 hours. So the total time taken by the bus to complete the entire journey is 25 over 6 hours. Total distance covered by the bus is equal to capital D, is equal to 300 kilometers. Therefore, the average speed of the bus for the entire journey is equal to S is equal to total distance covered over total time taken. And according to what we have calculated, the total distance is 300 kilometers, that is over 1, because every whole number over 1, all over the total time. And the total time we just calculated is 25 over 6 hours. So this is the speed. So now let's calculate for this. So we have S is equal to 300 over 1 divided by 25 over 6. Let's put this in bracket. And then the unit will be kilometers per hour. Let's continue over here. So we have S is equal to, bracket begins, 300 over 1 times, then we reciprocate what is here. You are going to get 6 over 25. That is kilometers per hour. Okay. So S is equal to, now 25 goes into itself 1, 25 goes into 312. So 12 times 6 gives us 72 kilometers per hour. So we say that the average speed of the bus for the entire journey is 72 kilometers per hour. B, if the speed of the bus in the first half of the journey is reduced to 50 kilometers per hour, determine its effects on the overall time. Okay, here the speed has, in the first half of the journey, has now been reduced to 50 kilometers per hour. So we put it there, 50 kilometers per hour. Okay, now time taken for the first half now is TR is equal to distance over speed. Now here the distance is the same, which is 150 kilometers over the speed, which is now 50 kilometers per hour. Okay, so 0 cancels 0, 5 goes into itself 1, 5 goes into 15, 3. So the new time is now 3 hours. Overall time after the reduction of time in the first half is equal to, now the new time in the first half is the 3 hours. So we are going to have 3 hours plus the time taken by the bus for the second half of the journey, which is still intact, which is 5 over 3. So this is over 1. We find the LCM of the denominators, which is 3. 3 goes into 3, 1. 1 times 5, 5. Plus 1 goes into 3, 3. 3, 3, 9. So this gives us 14 over 3 hours. Now, this 14 over 3 hours can also be written as 4 whole number 2 over 3 hours. Now, the 4 over 3 hours can be converted into minutes, and it is 2 over 3 times 60 minutes. 3 goes into 3, 1 goes into this 20. 20 times 2, 40. Better still, it can be written as 4 hours, 40 minutes. Overall time before the reduction of time in the first half, we have already calculated that to be 25 over 6 hours. So this can be written as 4 whole number 1 over 6 hours. Now, the 1 over 6 hours can be changed to minutes. So 1 over 6 times 60 minutes. This goes into this one, goes into this 10. So better still, we can say 4 hours, 10 minutes. Therefore, when speed in the first half was reduced to 50 kilometers per hour, the overall time increased by 4 hours 40 minutes minus 4 hours 10 minutes. 4 hours minus 4 hours gives us 0. 40 minutes minus 10 minutes gives us what? 30 minutes. So we conclude by saying that when the speed of the first half was reduced to 50 kilometers per hour, the overall time increased by 30 minutes. Subscribe, like, share, and discuss with your friends. Thank you.